Hello guys, and welcome back to another class of our course about the complete introduction to quantum computing. So in today's class we are going to talk about another topic, that is quantum computing algorithms. So what we're going to view in this part of the course are the different quantum computing algorithms that can exist. Well, we're gonna talk about the different types, and in the next few classes I'm gonna explain each of those types. And basically my goal here is really to present you each type of algorithm and what are the algorithms that are presented in each of the algorithm types. So you'll see it's advanced, but once again my goal here is really to bring you an introduction to different quantum algorithms so you guys can have a basic idea of what those algorithms are. So let's start. All right. So the first thing that we need to do would be defining what is a quantum algorithm, and not even defining what a quantum algorithm is, but simply defining what an algorithm in general is, because not everybody basically knows what an algorithm is. So basically, when we're talking about an algorithm, we can say that it's simply a step-by-step procedure to be able to execute an operation that can be, for example, a basic mathematical calculation, or a construction that can be put in sequences to resolve a certain problem with the use of a computer. So basically, as I said, it's instructions. We can say it's like instructions basically. So the algorithm will respect certain instructions to be able to resolve a certain problem, or to be able to resolve let's say a calculation, for example. Now to understand basically what exactly is the difference between a normal algorithm and a quantum algorithm. So it's pretty much the same thing. The only difference is that the problem is solved with the use of a quantum computer. So in a normal algorithm works on a normal computer. A quantum computer will work with on a quantum computer. So basically a quantum algorithm works with a quantum computer and cannot be run on a normal computer. So in other words, a classical algorithm can still be measured on a quantum computer, but basically it can, in a classical problem can be run on a quantum computer, but the reverse, it's not really, it can be possible, but it's a bit complicated. So basically in a quantum algorithm, what is the main difference is that in a quantum algorithm there is at least one step that is quantum. So in other words, this means it will work with the use of superposition or entanglement. So basically, at least one step of our instructions inside of our algorithm. So basically, as I said, it's a calculation or a series of steps. So basically, in at least one of those steps, we need to have a quantum step. So basically, when we're talking about quantum step, we can talk about, for example, entanglement or superposition. So if there is no step that are quantum, we cannot say that this is a quantum algorithm. It will simply be a classical calculation or a classical algorithm. Now, what are the different types of quantum algorithms that exist? So basically, there are some other types of quantum algorithms that exist, but those, in my opinion, are the most popular. So basically, we have, the first one will be the Fourier transform algorithm. And we can say that it's the quantum version of the discrete Fourier transform. So it also can be integrated very efficiently in in a quantum computer. So basically we can integrate it in a quantum computer and it will be very efficient. So for example, few examples of this type of algorithm could be, for example, in our case, the Shor or the Simons algorithm, which are the two most popular Fourier transform algorithms. And the Shor algorithm is pretty popular in quantum computing in general. The next type of algorithms that exist will be the amplitude amplification algorithm. So this type of algo works with a works with a certain space that is chosen from a quantum space. We can also say that this type of algorithm is a generalization of, in this case, the groove algorithm. So the Groover's algorithm, which is once again a part of the amplitude amplification algorithm. So we can have the Groover's algorithm and the quantum counting algorithm. Once again, those types of algos we're gonna talk about them a little bit more in depth in the next few classes. So I'll try to explain you a little bit the difference between the different types of algorithm. Next type of algo that we are going to talk about will be the quantum walk algorithms. So what we can say about it is that this type of algorithm is based on the classic random walk algo. So basically, which is a classical algorithm and can be viewed as the quantum version of this algo. We can describe this algorithm as a quantum superposition. You can say it's a superposition over some states. This algorithm can be an expansion, can exponentially grow the speed of execution of certain problems. So basically what it will do, it can, for certain problems, once again, it can really grow the speed of execution. So instead of executing some problems in, let's say, I don't know, a few hours, it's going to take you a few seconds, for example. And finally, we can have the classical algorithm, classical quantum algorithms, which can also be hybrid. Well, we can call it a classic hybrid quantum algorithms. So this type of algos are a combination of classical optimization and quantum state measurement. So basically, those will be the 4 algos that we are going to talk about in the next few classes. And you'll see, yeah, it sounds a little bit complicated, but I'll try to explain it as simply as possible and give you the best introduction possible to this type of algos. So that's it for this class, guys, and see you all in our next class.